Hello and welcome back to another video. In this problem, we're asked to prove the statement using the formal definition of a limit and illustrating with a diagram. So the limit as x approaches -2 of 3x plus 5 is equal to -1. So the formal definition of a limit states that the limit as x approaches a of f of x is equal to L if for every positive number greater than 0, which we're denoting by epsilon, there is an associated delta greater than 0, such that if 0 is less than the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. So let's plug in our values here. So this means that 0 is less than absolute value of x minus a. A here is the value that x approaches, so that's -2. So x minus -2 is less than delta. And f of x is 3x plus 5. Minus L is minus 1. This is less than epsilon. So therefore, 0 is less than the absolute value of x plus 2 is less than delta. And the absolute value of 3x plus 6 is less than epsilon. So we have to get a relationship between delta and epsilon to say, okay, no matter what epsilon we have, we can find delta from it. And so to do that, these inequalities have to match. And we'll notice that we have this bit right here that we don't have over here. And this is basically saying that the absolute value of x plus 2 is greater than 0. Now, the absolute value of x plus 2 is greater than all negative numbers. So the only number that this bit of the inequality excludes is 0. So this is basically the same as saying x plus 2 absolute value is not equal to 0. Therefore, x plus 2 is not equal to 0, and x is not equal to -2. However, since we're looking at the limit as x approaches -2 and not what's actually happening at -2, we can basically just ignore this, and we have the absolute value of x plus 2 is less than delta, and the absolute value of 3x plus 6 is less than epsilon. So now we need to get a relationship between delta and epsilon. So if we say this is equal to 3 times x plus 2, factoring out a 3, this is less than epsilon. You can factor the 3 out of the absolute value, and dividing by 3, we get the absolute value of x plus 2 is less than epsilon over 3. This absolute value is less than delta, and it's less than absolute, then it's also less than epsilon over 3. Therefore, delta equals epsilon over 3. So we have to prove that this relationship works. So if delta equals epsilon over 3, then x plus 2 is less than epsilon over 3. Multiplying both sides by 3, we get 3 times x is 3x, 3 times 2 is 6, is less than, if the 3's cancel, epsilon. Therefore, 3x, this is 3x plus 5 plus 1. This is f of x, 3x plus 5, plus 1 is minus -1. Therefore, f of x minus L is less than epsilon. So from this relationship, we can prove that this is true if this is true. Now we just have to show what that means with a diagram. So we're saying that we have our line, 3x plus 5, and at -2, as x approaches -2, and we take this with values close to it, -2 plus delta and -2 minus delta. So within this interval, we get y values on the function that are near our y value of -1. And specifically, they're epsilon away. And we're saying between these 2 points, all the values on the function are going to be between these 2 points, and therefore the limit exists.